Hey, this is Mr. Beckstrom, and today I wanted to do a problem from A6, completing the square. And we have a quadratic here, 5x squared plus x minus 1/4 is equal to 0. We should already know a couple of ways to try to solve this. Looking at it right now, I probably use the quadratic formula. But completing the square is another method. There's a couple of different ways to do it, but the idea is that we're going to write the quadratic in such a way that we can then rewrite it as a binomial squared, and then we can solve from there. So I'll go ahead and show you. And we're going to get a kind of a nasty answer when we do this. So let me see here. So the first thing I want to do is I just want to get, oops, I want the x squared term and the x term on one side, and then I want to move the constant term on the other side. So we're going to have to add 1/4 to both sides. So I get this. And this will allow me to figure out what I need to do uh, in order to complete the square. So the next thing I want to do is I want to factor out any value that's in front of the x squared term. So in this case, there's a 5. So I want to factor that out here. So 5, and I'm going to get x squared plus, we also have to divide the 5 out of 1. So 1 divided by 5 is just 1/5 x, and that's all equal to 1/4 over here. Alright, so now that we factored out the 5, and this is confusing to a lot of students, so I just look at it. If you were to multiply it back, 5 times 1/5 gives you the 1 that's really in front of this x over here. So that's kind of how you have to look at that. Alright, so now that I have the x squared term by itself with nothing out front because we factored that 5 out, I can complete the square. And the way that I do that is I take the coefficient, that's the value that's in front of my x term, I divide it by 2, and then I take that and I square it. So let's kind of do that off to the side. So if I take 1/5 and divide that by 2, which is just the same thing as multiplying it by 1/2, that's going to give me 1/10. Now this 1/10 is what I'm actually going to use in my binomial, so I want to remember that or keep that written down. But then in order to find what I need to complete the square, I'm going to take the 1/10, and I'm going to square it. And that gives me 1/100. So that's the value that I need in order to write this here as a binomial squared, and I'll show you what that means in just a second. So I'm going to go back over here, and 5x squared plus 1/5 x plus 1/100, right, is equal to, I just added, what did I really add over here though? I didn't add 1/100 because once I distribute that with the 5, I really added 5/100 or 1/20. So that's really what I added to this side because I'd still have to distribute it back with this 5 in order to figure out what I really added to the left side of the equation. So what I added was 5/100. So I'm going to go ahead and use that. Is equal to 1/4, and since I added 5/100 to this side, I'm going to add 5/100 to this side, or I could have wrote that as 1/20. Now we're going to go back over here. Now we have a perfect square that we can write as a binomial squared. Because this last term is half and then squared of this term, we can rewrite it. And the way we can rewrite this now is x plus that first value that we got, the 1/10. If this was a minus, it would be a minus, but plus the 1/10. That's why we remembered that first thing that we got. And that's squared. Now, this is a binomial squared here, and if we were to actually FOIL this out, we would get this back. So in order to write something as a binomial squared, it has to meet certain conditions, and that condition is that that constant value in it is half and then squared of that middle value. So since we wrote it that way now, we can rewrite it as this, which is going to help us in just a minute. And this is equal to, if 1 over 4 is the same thing as 25 over 100, so 25 over 100 plus 5 over 100 is 30 over 100, which is 3 over 10. So all I'm doing is adding these two together and simplifying. Now I want this squared binomial by itself, so I can divide both sides by 5. So I'm going to get x plus 1 over 10, we'll see if we have enough room, is equal to, well, dividing both sides by 5 is the same thing as multiplying both sides by 1/5. So 3/10 times 1/5. I'll kind of do that to both sides just to show you there. That's just 1 there, and then this is 3 over 50. So this is 3 over 50. All right, and let me kind of cross this out. We'll do one more line over here. So the next thing I want to do is, now that I have a term squared by itself on one side of the equation, I can take the square root of both sides. So this is going to be x plus 1 over 10. So I took the square root of it, is equal to, and remember we have to do the plus or the minus because we're taking the square root of both sides. And just think about it this way. If you took the square root of 25, you have two answers, right? You have 5 times 5, but you also have -5 times -5. So -5 and 5 are both the square root of 25. And that's just an example, not this specific one. Is equal to, and then we're going to take the square root of this side. 3 over 50. So we just took the square root of both sides, and the last thing I want to do is I want to subtract 10 from both sides. I'll do it over here. Excuse me, 1/10. So x is equal to plus or minus the square root of 3 over 50. And this is going to be minus 1/10. So this is actually two different answers. Both of these are an answer, so really if I want to look at them separately, my x1, that would be my first x answer. I'll just look at the positive of this. It could be the negative, but usually, so we can just write the positive of that, because plus or minus means that it's two different answers. Minus 1 over 10. And then I could say my x2, or my second solution, would be the negative, would be the negative of this over 50 minus 1/10. So those are your two solutions. Now if we were to use the quadratic formula, I think we would get the answer quicker. It wouldn't look like this because it would all be kind of one square root, whereas this is two separate expressions or two different terms. Probably get one term if we were to use the quadratic formula. If you have any questions, let me know, and I hope you have a great rest of your day. Thank you.